Hello and welcome back. Today we're going to jump into our third part of geometry here, coordinate geometry. Here we're looking at the coordinate grid. When we think about coordinate geometry, we are talking about x, y coordinates, how the x and y axes relate to one another. So we can think about the x-axis running left to right, similar to how east and west work on a map, and the y-axis runs up and down to the north and south. Let's take a look at an example. Here is our x-axis going from east to west, and our y-axis going from north to south. Both axes work like number lines in positive and negative directions, stretching infinitely in both directions. Let's take a look at what we call ordered pairs. This is an ordered pair, and this is an ordered pair. Ordered pairs always go in the sequence of x, y. What this means is that we go back -4 on the x-axis first, and then we go up +5 on the y-axis to get to our point. This ordered pair represents a point on the coordinate grid. Ordered pairs indicate where on this map to plot points. The first number always refers to the x-axis, and the second will always refer to the y-axis. Now, all of this is relative to where the x and y axes cross one another. This is called the origin. The origin is 0, 0. This is where they cross one another. All points are relative to our origin of 0, 0. All other points would be in reference to this origin of 0, 0. Everything to the right of the origin has a positive x value, while everything to the left has a negative x value. Points above the x-axis have a positive y value, while points below the x-axis have a negative y value. We can think of this concept as like the equator that splits the Earth into two. Now, let's try to plot some of our own points. Let's plot the point. The ordered pair here will be 1, 7. That's positive 1 for the x-axis and positive 7 for the y. So let's go up 1 on our x-axis, to the right 1, and then we can go directly up 7, up the y-axis. 1, 2, 3, 4, 5, 6, 7, to land us at about right here. This is 0.17. Now let's try another one, negative 1,7. Now we will go to the left 1 to go back negative, but we still have a positive 7 for y. We'll plot our point here. Now we see negative 1,7 as a point and positive 1,7 as a point. What about 1, negative 7? Now we're going to go up 1 on the x-axis and down 7 on the y, which will place us here. Now what happens when we connect our dots together? Let's connect. It makes a triangle. Now let's talk about the formula of a line. The formula of a line is y equals mx plus b. This is called the slope-intercept form. This is because it shows the slope and the y-intercept. The x and y in the formula represent the two parts of an ordered pair. M will represent the slope. This shows how steep or shallow the line's incline or decline is. positive slope means that the line will rise from left to right. And a negative slope will descend from left to right. To find m, we'll need 2 points along the line to find the rise over run. Slope is an expression of rise over run. Any 2 points will define a line by connecting them together, so it does not matter which you use. The rise refers to the change in the y-axis. And the run to the change in the x-axis. Let's take a look at another formula that we can use to calculate the slope. We just need to be sure to remain consistent as to which point we call the first point and which we call the second. That way we can stay consistent with the numerator and denominator. Here's our slope formula. M equals y2 minus y1 divided by x2 minus x1. Let's go back to our coordinate grid. For example, if we are comparing these two lines together, these 2 points, these two ordered pairs, these 2 points, which will form a line straight across. Notice this will have 0 slope. It does not go up or down. We can use our formula by labeling these. This can be x1 and y1. This pair can be x2 and y2. We just need to be careful that we understand which one we've labeled the 1s and which ordered pair we've labeled as the 2s. As we see in our formula here, y2 minus y1 divided by x2 minus x1 will get us our slope, or m. M is slope. Now let's try a practice problem. Bring in our notes as well. Points 2, 6 and negative 1, 0 lie on a certain line. What is its slope? Here we can use the slope formula for our xy ordered pairs. Let's call 2, 6 our first point, x1, y1. And negative 1, 0 can be our second pair. x2, y2. So let's put that into our formula. We'll plug these values into our slope formula. So the equation will read y2 minus y1, 0 minus 6, divided by negative 1 minus 2. This will give us negative 6 divided by negative 3. Or 2. Our answer is C, 2. Now we'll get more into working with negative numbers as we cover advanced math. But this is coordinate geometry, where we can use the coordinate grid and ordered pairs in order to find information about lines, which in the real world we then connect to all types of areas of study, such as statistics especially, but also other sciences as well. I'll place problems on the classroom discussion board, and we'll see each other next time. Take care. The other important component to slope-intercept form is the y-intercept. This will be the y value when x is 0. You can find this point if you know the slope and any one point. So in our previous example here, the slope is 2. And we already know 2 of the points. So the formula should read y equals 2x plus b. If we'll remember, our slope-intercept form is y equals mx plus b. Now we have a formula. We have a line forming here. We're going to solve for b. B is our y-intercept. This is where the line crosses the y-axis. Let's solve for b. We'll choose a point to plug in for x and y. Let's choose 2, 6. Now the equation will become 6 equals 2 times 2 plus b. Now let's multiply 2 and 2 together to find that 6 equals 4 plus b. Now we can subtract 4 from both sides to isolate our b variable. Here we find that b equals 2. Since b equals 2, the point 0, 2 must also be a point on the same line. So our final equation to the line containing all of these points will be y equals (2x plus 2). And this will be finding the y-intercept, or y value when x is equal to 0.